Welcome to Mrs. Bibb's Algebra 2 class, first 9 weeks, week 7. If you'll please fill in your table of contents. Then if you'll complete your warm-up, you'll need a piece of notebook paper. Just take notes as I write down. You do not have to write down the essential questions that I have listed here, but by the time that we're finished, you will be able to answer every one of these questions. If you'll please write down simplifying radicals and then write down these 3. I've made a list on the side here. It's just 1 times 1, 2 times 2, 3 times 3, so on and so forth. This list comes in handy when you're simplifying radicals, so if you'd like to write down that list, pause the video and write it down. A method I'm going to show you to simplify radicals will involve using this list. First of all, when you look at the square root of 81, is the number 81 in this list? Yes. What number do you square to get 81? 9. So the square root of 81 is 9. That one was relatively simple. Question 2, the square root of 200. Is 200 in this list? 200 is between 196 and 225. We do not want decimals when we do these problems. This is what I suggest that you do. Write down the factors of 200, the things that multiply to give you 200. 1 times 200. 2 times 100. 3 won't divide evenly into 200. 4 will. 4 times 50. 5 times 40. 6 will not go into it. 7 will not go into it. 8 times 24. 9 will not divide evenly into it. 10 times 20. These are all the factors of 200. Now, this is my advice. Looking at this list of numbers and this list of numbers, 149, find the largest one over here that's found in this list. I see 4, and 4 is over here, but is that the largest perfect square? 100. 100 is my largest perfect square that you can find over here. So once you find that largest perfect square, then rewrite the square root of 200 as an equivalent expression. The square root of 100 times the square root of 2. We already said that 2 times 100 is 200. So the square root of 100 times the square root of 2. What is the square root of 100? 10. And I can't simplify the square root of 2, so my simplified answer for the square root of 200 is 10 times the square root of 2. Let's try number 3. Factors of 75. Now, looking at this list of factors, find a perfect square, the biggest perfect square that you see over here. Hopefully you see it's 25. Rewrite the square root of 75 as the square root of 25 times the square root of 3. What's the square root of 25? 5 times the square root of 3. I'd like for you to try the next 3 examples. For number 4, I made my list of factors. I highlighted the 2 perfect squares that are in this list over here. The biggest one of those 2 is 16. The square root of 16 times the square root of 6 is 4 times the square root of 6, which is 4 square roots of 6. Same thing for number 5. I wrote my list of factors. 25 was the only perfect square in that list. So the square root of 375 is the square root of 25 times the square root of 15. This would be 5 times the square root of 15, which is 5 square roots of 15. Same thing for 32. I wrote a list of factors. The biggest perfect square in that list is 16, so the square root of 16 times the square root of 2. The square root of 16 is 4 times the square root of 2, best written this way. So I hope you got those correct. The next thing that we're going to do is solve these simple quadratic equations. When we're solving simple quadratic equations, we need to express our final answers in simplest radical form if need be. If you'll please write solve and then write down at least the first example. When you're solving these, you want to get x squared alone. Pretend like this is just 4x equals 4. What do you do to get x squared alone? You divide by 4. X squared will equal 1. First thing I want us to discuss is that what number or numbers can you square to get 1? You can square 1 to get 1. You can also square negative 1 to get 1. Negative 1 times negative 1 is 1. The process or the work that you show to solve this is to unsquare x squared, you take the square root. The square root of x squared is x. We are solving a quadratic equation. A quadratic equation has two solutions. So that's why we use the symbol plus or minus. The answer is plus or minus the square root of 1 is 1. I want you to notice that this answer is what this says. Plus or minus 1 is positive 1 or negative 1. Let's look at number 8. I'm going to solve number 8. I'm going to divide both sides by 8. X squared equals 4. Then I'm going to take the square root of both sides. X is going to equal plus or minus 2. The reason that you have plus or minus 2, remember, what can you square to get 4? You can square positive 2. 2 times 2 is 4. What else can you square to get 4? Negative 2. Negative 2 times negative 2 is also positive 4. So there are two answers to this problem. Let's try number 9. I'm going to divide by 14. X squared will equal 4. Take the square root. X equals plus or minus 2. Okay, let's look at number 10. I want to divide by 7. X squared will equal 8. Then I want to unsquare this x, so I'll take the square root. X will equal plus or minus, because I need two solutions, a positive solution and a negative solution. But this is not a perfect square. You have to think about this problem the way we were doing those other problems on the previous page. The factors of 8 are 1 times 8 and 2 times 4. 4 is the perfect square. You've got to simplify the square root of 8 into the square root of 4 times the square root of 2. Then that would be plus or minus 2 times the square root of 2, and it is perfectly fine if you skip to this final answer, plus or minus 2 times the square root of 2. And I want you to realize, you don't have to write it this way, but I want you to realize that you have two answers, positive 2 square root of 2, and you also have negative 2 square root of 2. Those are the two solutions to that quadratic function. Why don't you try number 11 and number 12? For number 11, I got down to this answer, plus or minus 10 divided by the square root of 3. I'm going to talk first about how I arrived there, and then I want to share something with you. I added 2 to both sides first, just like I would if this were just 3x minus 2 equals 98. I divided both sides by 3. 100 is not divisible by 3, so I have 100 thirds. I took the square root of both sides. When you have a fraction, you want to separate that radical. You want to put a radical in the numerator and a radical in the denominator. These are equivalent. 100 is a perfect square, so the square root of 100 is 10, and then I have the square root of 3 in the denominator. Now, looking at what I have written, this is not finished, technically. You cannot have a radical in the denominator. You can't have an irrational number in the denominator. So, I need to rationalize my denominator. How do I go about doing that? To rationalize the denominator when your fraction looks like this, all you do is multiply your numerator and your denominator by that radical. That's how you rationalize. That's how you get rid of your irrational number in the denominator. I'll show you how. And also, when you do this, you're multiplying by 1. And when you multiply something by 1, you do not change its value. I'll keep my plus or minus sign. 10 times the square root of 3 is 10 square root of 3. The square root of 3 times the square root of 3 is the square root of 9. And then hopefully you notice that that will simplify into 10 times the square root of 3 over 3. The square root of 9 is 3. So that is my final answer for number 11. 10 times the square root of 3 over 3. Here's my answer that I got for number 12. I divided both sides by 19. I took the square root of both sides. I made a list of the factors of 52. And 4 is the only perfect square in that list. I took the square root of 4 and I wrote it in simplest form. On to number 13 and 14. They look a little bit different, but they're not too difficult. I cannot subtract this 3 away from 2x because this is joined together by the parentheses and squared. So I have to get rid of the square away from this binomial before I can get rid of the 3 and the x. How do I unsquare the square? I take the square root of both sides. So I have 2x plus 3 equals plus or minus 4. Because the square root of 16 is 4. Remember, when you take the square root of both sides, you have to put a plus or minus sign. Now, this means I have two equations to solve. I have 2x plus 3 equals positive 4 to solve. I also have 2x plus 3 equals negative 4 to solve. Now let's solve those. I'll subtract 3 from both sides. Then I'll divide by 2. One half is one of the solutions. Next, I'll subtract 3 from both sides. 2x will equal negative 7. Then I'll divide by 2. X will equal negative 7 halves. The two solutions are negative 7 halves and 1 half. Now, if you will try number 14, I will tell you that you need to move this to the right first. The answer to question 14 is probably very different from what you're used to seeing. The first thing I did was add 5 to both sides. 12 plus 5 is 17. I brought down x plus 2 squared equals 17. Then the next thing I did was take the square root of both sides. The square root of x plus 2 squared is x plus 2. The square root of 17 would be a decimal if I tried to take the square root of 17, so I left it. Don't forget your plus or minus. To finish, to solve, I need to find x. I need to get x alone. So I subtracted 2 from both sides. Notice this arrow I drew here. This is where you should subtract 2 from, so that your final answer looks like x equals negative 2 plus or minus the square root of 17.